Practice problem number 1 states that the difference between k and 2 divided by 5 is equal to 11j, or 11 times j. And we are asked to solve for the variable k. What does that mean? That means we want the variable k on the left side of the equal sign all alone, and we want all the other terms to be on the right side of the equal sign. So looking at this equation, we do want to get rid of the fraction, right? So in order to do that, we can multiply both sides of the equal sign by the denominator, 5. So let's go ahead and do that now. Now, if we put a 1 underneath the 5 here, we can see that since we're multiplying these two fractions together, we can cancel out the numerator and the denominator, which both contain a 5. That is going to leave us with k minus 2 on the left side of the equal sign. On the right side of the equal sign, we have 5 times 11j. Now we do not want to distribute out the 5 to the 11 and the j. And the reason why is because 11j is a single term, 11 times j. So what we're going to do is multiply the 5 times 11 and multiply that by j. So we're left with 55j. Okay, so we're one step closer, but we do need the k on the left side of the equal sign all alone, but he has the negative 2 with him. So we need to move the negative 2 to the right side of the equal sign, and we can do that by adding 2 to both sides of the equation. Notice here that I put a plus 2 on the side, and the reason I did that is because 2 and 55j are not like terms, so we cannot add them together to get 57j. Right? What are like terms? Same variable, same power. This one does not have a variable, and this term does have a variable, j. So they are not like terms. Let's go ahead and move forward. The k is going to drop down. The negative 2 plus positive 2 is going to turn into 0. And we're going to say is equal to 55j plus 2. And so we have the k on the left side of the equal sign all alone, and we have all the other terms on the right side of the equal sign. So we can go ahead and box this. Problem number 2 states that a times the difference q and 8 is equal to 23. And we are to solve for q. So looking at this equation, we can see the right side of the equal sign is already simplified. We cannot run PEMDAS on it. The left side of the equal sign, we can, right? So let's go ahead and take a look. First, we look at the parentheses, and the parentheses is simplified. There's nothing left to do because the q is not a like term with the number 8. Okay, so there's nothing left to do inside of the parentheses, but what we can do is distribute out the a. Alright, so let's go ahead and distribute out the a to every term in the parentheses, and so that is going to be a multiplication. So do a times q is a times q, and we'll do positive a times negative 8 is going to be a negative 8a is equal to 23. Now we need to solve for q, right? So we want the term with the q on the left side of the equal sign. He's where he's supposed to be. We want the terms without q on the right side of the equal sign. So this term here, the negative 8a, needs to move, right? And to be aware that this is not 8a, this is negative 8a. So to move them to the other side of the equal sign, we need to add 8a to both sides. Notice here that I did not put the 8a underneath the 23 and add them together, because they are not like terms. They do not have the same variable with the same power. So let's go ahead and rewrite this equation. And we'll say a times q is equal to, and I'm going to put the term with the variable in front of the 23, the term without the variable. So we get 8a plus 23. Now, we're almost there, but to solve for q means we have q all alone on the left side of the equal sign, and we have all of the other terms on the right side of the equal sign. So we need that a to make its way to the right side of the equal sign. And to do that, we are going to divide both sides of the equation by a. That's going to leave us with a divided by a is 1 times q. Leaves us with q is equal to 8a plus 23 divided by a. And that is our final answer.